Good evening, participants. Today we have the session by Dr. S. Venugopal. Venugopal sir, join. Hello, Venugopal sir. I think he's joining. Please wait for 1 minute. I will check with the resource person. The resource person will be joining in a minute. Participants, please wait for 1 more minute. Sir, is that okay?
Okay.
Hello, sir. Am I audible
Hello.
to you?
It's audible.
Sir, you are not audible.
Oh, I'm not audible. No?
Sir, are you talking?
Yeah, I'm talking now. Now it is audible.
Yes, sir, you are audible. Saibi
Yeah,
ma'am, sir is audible.
Is anyone, is it my problem? Can anyone hear what Venugopal sir is saying?
Saibi ma'am, I think you have some connectivity issues. Sir is audible and you are also audible.
So I am repeating now. Is it audible now?
Yes, sir, you are audible.
Sir, we will start with a brief introduction.
Yes.
Hope I am audible to all.
Yes, it's audible.
Yeah, thank you.
So how many people we are expecting? No? If I know it is.
Yeah.
25.
So today we have Dr. Sri Venugopal S. He completed his Bachelor of Technology from University of Kerala, Chemical Engineering, and he did his Masters of Business of Administration MBA from University of Kerala in Operations and HR, and he also did his MSc in Indian Institute of Ecology and Environment in Ecology and Environmental Engineering. He is doing his part-time research fellow at University of Kerala, and he has received many awards and recognitions. He received his doctorate in environmental engineering and management from MS World Culture and Environmental Protection Commission from Government of India, Teen Murthy Bhavan, New Delhi, and he also received Best Quality System and Innovation Award in Very Large Industry category conducted by Safety and Quality Forum of Institution of Engineers India, Delhi, at Gandhinagar, Gujarat, and he received honorary doctorate in the specialized areas of training and management from Commonwealth Vocational University, Kingdom of Tonga during June 2020, and he received National Award first in the category of Best Trainer from National Rubber Skill Development Council, New Delhi. And also he received a national award as Best Professional Trainer in Management and Skill Development from Education Council, New Delhi. And he received Best International Global Trainer Award during the year 2020, and also received Lifetime Achievement Indian Glory Award for the contribution in management training during 2021. He received Global Training Award, Global Teaching Excellence Awards in 2021 for the innovative CSR model in teaching and management subjects. He has over 31 years of organizational experience. He currently working as a general manager in quality and safety trainings, responsible for technical training for all the units of HLL Life Care Limited. He worked as General Manager in HLL Life Care Limited and has experience in various functions such as production, quality, safety, environment, testing, management representatives in various units of HLL for over than 28 years. And apart from that, initially he served as MS Apollo Tyres Limited as senior officers, or also he worked in Taru Lalwani Group of Companies, Chennai, as environmental engineer. He is also a certified technical assessor of NABL for mechanical testing performance, durability, safety test, and rubber latex products, including medical devices, and conducted 10 external certification audits. And he's also a certified quality system Six Sigma Black Belt from Confederation of Indian Industries Six Sigma Black Belt professional with demonstrated experience in practical implementation and ongoing success of Six Sigma methodologies. Certified Chartered Engineer in Chemical Engineering stream from Institution of Engineers, All India Chapter. Also lead auditor ISO 9001-2015 Quality Management System. Lead auditor ISO 14001-2015 Environmental Management Systems, and certified assessor and trainer of Rubber Skill Development Center for Rubber Related Training Council. Certified assessor on India Manufacturing Excellence Award of Miss MS Frost and Sullivan, UK. Certified assessor for the Business Excellence Model. Certified Quality System Internal Auditor on ISO 45001 2018, SA 8000, ISO 15181, and NABL and Medical Device Regulation. He has a contribution to the professional achievements. He has implemented MDR as part of CE marking based on revised regulations and framed MDR technical file for male and female contraceptive condoms. And he developed a quality improvement team of PFT and implemented 100 quality improvement projects in the year for the year 2024-25. And he has hands-on experience in handling QA activities in hospital product manufacturing unit of HLL manufacturing, blood bags, copper T, surgical structures, tubal ring, and hydrocephalus shunt and MR functions. And she has implemented several environmental initiatives and innovations, including design, commissioning, and validation of ultrafiltration and reverse osmosis plant for the reuse of water for process applications, and contributed for the expansion, modification of effluent treatment plant, and implement zero liquid discharge systems in HLL. Also, he has implemented various TQM concepts and Six Sigma projects and lean concepts approach across HLL. Approved accessor and coordinator of Rubber Skill Development Center, and for conducting rubber skill development programs and certification courses of HLL Management Academy. His core competencies include a rubber skill development training program for the manufacturing employees and chemists of HLL and other rubber manufacturing companies in Kerala, and total quality management, quality improvement programs, Six Sigma statistical process control, and 7 QC tools, lean manufacturing, manufacturing excellence, business excellence models, zero defects, Kaizen and POC, rubber technology, effluent treatment systems, including ZLD systems. Also, he has memberships in various forums, and he has published 15 national level and international publications relating to management operations, quality, environment, and environmental related journals, and received best papers from 5 research publications relating to environmental quality. With this brief introduction, I welcome Sri Venugopal sir to deliver talk on faculty development program on sustainable engineering and carbon neutrality. Welcome you, sir.
Okay. So good evening, ladies and gentlemen. So thank you, Mrs. Sebi, for giving the nice introduction about me. So today's online FDP program, so titled Sustainable Engineering and Carbon Neutral. So I was fascinated to invite me as a speaker for this program. So let me come to my topic now. So basically, I am focusing on this topic, sustainable engineering and carbon neutrality with respect to the chemical industry or process operations. So mainly the focus with respect to the chemical process operations of various industries across the globe. Is the slide visible? Is the slide visible now?
No, sir.
Slide is visible?
No, sir.
It's not visible. No? Okay.
Not visible, not visible.
Now it is visible?
Yes, sir.
Yes, it's okay now. Okay now.
Okay. Okay, so good evening. So again, coming back to the program, the title Sustainable Engineering and Carbon Neutrality. So my focus with respect to the chemical process operations of various industries, building a greener future. And my top, is it audible also, Nick? Is it audible?
Yes, sir, audible.
Audible, sir.
Okay. So my focus is with respect to various chemical process operations of various industries across the globe, and a special reference to HLL also, because we are doing a lot of sustainable activities to reduce the carbon footprint, etc. So I am going some case studies also. I am going to present this as part of that. So first, let me have a small introduction about the development with respect to the science, technology, and industry, the modern era, right from the sprawling urban centers to the complex supply chains which connects the nations, and the human integrity has been reshaped the planet in profound ways. So the progress has been triggered in the as one of the greatest challenges in the humanity, and this concept has been raised due to the rising global temperature, increasing greenhouse gas, then melting glacier, deforestation, and pollution, etc. It's a collective reality of this modern era. So the basic urgent question is how to continue the advancing society without determining the ecological systems which sustain the life. So in that context, the sustainable engineering and carbon neutrality plays a major role in the global conversion on the climate change as well as the environmental stewardship. So basically, the sustainable engineering is which provides the practical framework for designing, developing, and maintaining systems that minimize the harm to the environment. So it prevents the deterioration of the environment while meeting the human needs. So sustainable engineering basically designs solutions that meets the present needs without compromising the future generations, etc. So basically, we have importance with respect to the climate change, resource depletion, and global warming, and there's a lot of involvement. There's a lot of things. The role of engineers is there in shaping the stream. So that is one part of this picture. Second part is the carbon neutrality represents the ultimate goal, which ensures that human activities no longer contribute to the dangerous accumulation of the greenhouse gas in the atmosphere. So basically, it is the concept relating to the reduction of GH in the atmosphere, etc. And the link between there's a link between these two, which is inseparable. This sustainable engineering supplies the necessary inputs like tools, technologies, design, etc. to reduce the emission and to conserve the resources, while carbon neutrality provides a targeted outcome with the available resources supplied by the sustainable engineering. So basically, we have to have a balance between the human activity and the natural resilience for the long-term survival and prosperity in our nation. No, first, before going to that, we see what is the concept of sustainable engineering. So basically, it is a deliberate integration of the environment, social, economic consideration into the engineering, design, and practice in every field of the industry. Like we do right from the product design, process design, then comes the manufacturing, testing, quality, then engineering. All that comes under the sustainable engineering comes in their role. So since the conventional engineering, which focuses on the efficiency, productivity, and cost reduction, sustainable engineering adds a long-term perspective. It just has a long-term effect on the environment as well as the process. So it seeks the solutions which are not technically sound and economically viable, but also environment responsible and socially critical. So it is a dimension of 3-4 areas like technology, then economic operations, then environmental and social commitment, etc. So basically, at the core, sustainable engineering is about how to have a balance. So engineers must balance the present needs with the future needs, industry growth with the ecological protection, and innovation with the conservation. So this approach ensures that the progress today does not undermine the potential of the future generation to thrive. Now let us see the core principles involved in the sustainable engineering. So there are several guiding principles which define the sustainable engineering. First, the resource efficiency. So this systems, we should have a systems which use the raw materials and energy, which will maximize the output, and we have to have the green economy, the operations, etc. And we have to minimize the waste. So we have to increase the efficiency, which reduce the cost and help to preserve the natural resources. So it focuses on cost reduction, maximum output, then economy of the scale as well as the resource conservation. Second is the waste minimization and circularity. So basically, the concept of sustainable engineering starts with the circular concept or circularity concept, because right from the raw material up to the product. So it's called a circular economy model. So it is called a life cycle approach, which sustains the reuse, recycle, and repurpose of the products as well as the ingredients, etc., produced in different stages of the manufacturing process. So basically, that circular economy plays a major role for building an effective, sustainable practices in the organization by waste minimization. Third is with respect to the energy optimization. So as part of industry 4.0, we have to focus on the renewable energy, which have green efficiency and which reduce the dependence on the fossil fuel, etc. And the last point of this principle is the life cycle perspective. That is, every product has got a lifespan, and we have to ensure that right? As a manufacturer or as well as a service provider, we have to ensure that the product, right from the design, from the resource extraction at the raw material stage to the use as well as the final disposal of the product by the customer, ensures that the environmental costs are being taken care and the life cycle of the product is being taken care, and which will not affect the environment. Next point is the resilience and adaptability. This basically the manufacturing systems must be designed to withstand the changing condition like social, economical, and technology, etc. And finally, the social responsibility, that like engineering decisions. So any engineering decision should be focused on the social, like HSC, like health, safety, environment, as well as social equity, etc. So there's an interconnection between this, between the people as well as the environment. So these are the core principles behind the sustainable engineering. So once you have a sustainable engineering principles in hand, we should have then we can have a system to have carbon neutrality. So basically, the historical background of sustainable engineering moves prior to the mid-20th century, where engineering and industrial expansion was totally ignored, and they also ignored the ecological consequence based on the industrialization. And the industrial revolution also, of course, it has been characterized by the use of coal, then emissions, controlled emissions, etc., and mass extraction of the resources, etc., all aimed at fueling the growth of the organization. But during 1960s and 1970s, we can see the environmental crisis like oil spills, polluted rivers, which triggers the publica. So, of course, the dangers of pesticide has been formed. And finally, we have been a milestone, which is in 1972, we have a Stockholm conference. In this, we have the Earth Summit, which emphasizes the integration of the environment with the sustainable activities for development. Then finally, the engineering is a discipline which is involved in the response. So universities incorporates sustainability in the curriculum of all the branches, etc., and professional organizations. They introduce the guidelines and the eco-friendly design. And sustainable engineering is not a niche, but it's a mainstream requirement across all the industries. So it is an engineering about the long-term solution. It does not focus on the short-term solution. So it focuses on the long-term solution, which minimize the environmental impact. And the major challenges takes care of like climate change, resource depletion and pollution, and also which reduce the carbon footprint in industries, like all the industries, like in manufacturing, construction, transportation, etc. And also it acts as an energy efficient catalyst in developing more renewable technologies, and of course the circular economy practices to ensure the life cycle of the product. Now let us see this life cycle, because the life cycle perspective is very important aspect in sustainable engineering to have a carbon neutrality. So the powerful tools in the life cycle approach, right from the raw material extraction. So we have to find what is the source of raw materials, whether the raw materials are natural made or synthetic products, synthetic raw materials, and are they renewable and non-renewable, and what about the cost and availability, and what about the quality? Because if there's a natural product, of course there may be variation in the quality, etc. So that part should be taken care. Second is with respect to the manufacturing. So how we are doing the process, we have to find how much energy is consumed. We should have a material balance as well as the energy balance, and see what are the emissions generated during the production. Third is the distribution of and the use in terms of the customer point of view, how it is being transported to the customer, and what is the environmental footprint during the use. And finally, the end of life, that how we can, as customer can safely recycle the product or dispose the product. So these are the life cycles, so 4 aspects of life cycle perspective in the sustainable engineering. Of course, these core principles we have studied: use waste minimizing, eco-friendly, life cycle thinking, and social economic responsibility. Now let us see what are the strategies. So the basic, we should have a input as a sustainable engineering. Now let us see what are the strategies to achieve the carbon neutrality. So once we want to attain the carbon neutrality, we should have these core principles as well as the systems for sustainable engineering in practice. And the strategy, first strategy is the use of renewable energy concept like solar, wind, etc. Second is we should have energy efficient like systems like smart grids, green buildings, etc. Then we should have a green manufacturing process, like throughout the manufacturing process, right from the raw material to the product. We should have a green manufacturing, which involves the circular economy, etc. And finally, the carbon capture and the storage, of how we can reduce the carbon footprint, how we can we can store the carbon, and how we can capture the system. And of course, we have offsets, like we could protect protection of the environment, etc. So these are the strategies which we need to have to achieve the carbon neutrality from the sustainable process. So the life cycle perspective, there are a lot of hidden costs involved, especially basically if you take about plastic product, it is, even though it is maybe cheap to produce, but this effect on the long-term disposal may cause a long-term environment harm. So in the part of regulatory aspect, you should have a system called the plastic. The plastic processing. It is a primary responsible of the manufacturer. So it is called a manufacturer responsibility to ensure that the product has been disposed safely. So it is a job of the manufacturer. That is, it is called a manufacturing responsibility. It is called. Then second is the renewable technologies like solar, wind turbines, etc. They should be evaluated, and the energy requirement should also be calculated as a long-term impact. So it is so we have the producers' responsibilities and technologies, and also we should have a life cycle thinking approach. We ensure that we should select the choices to ship that which will not have damper the environment. So now comes the scientific basis of the carbon neutrality. So any industries, the scientific basis one is we have to understand the greenhouse gases. So to appreciate because most of the industries as part of carbon neutrality, greenhouse gas being emitted like carbon monoxide, NO2, NOx, and sulfur dioxide, etc., from the stack, etc. So the earth, Earth's atmosphere also contains these gases like carbon dioxide, methane, etc. So what happened now? This gas being trapped heat from the sun and keeping the planet warm and give enough to the support life, and it is called a greenhouse effect. So the basic purpose as part of carbon neutrality, like we have to follow we have to reduce the emission of the greenhouse gases. So what industries are doing now, we have to have zero emission. So zero emission we can put. So we can use alternate fuels other than furnace oil, diesel oil, etc. for our operation. We can use an LNG or liquefied natural gasoline or LNG or a CNG for our operations for boiler, etc. Which gives absolutely no emission, zero emission from the stack, which ensures that we have been protected and the carbon neutrality. So that is the most important thing which we have to give. That is the which is called a CNG or LNG, liquefied natural gas. We have to meet it. So basically, as part of industrial revolution, you can see the carbon dioxide PPM also has been now drastically increased. Earlier it was 280 ppm, now it has been increased. So industries have been contributing to increase the ppm of carbon dioxide from 280 to 420 over the years, etc. So we have to have more focus on the control of the emissions from the stack during the industrial operation. So this accumulation of this also leads to greenhouse gas effect leading to global warming. So there's a rise in temperature above the temperature, about the surface temperature, etc., causing the global warming, etc., which also leads to the consequence of sea level, stronger storms, prolonged droughts, wildfire, etc., which affects the ecosystem. Now, the concept of carbon neutrality is always expressed in terms of net zero concept. It is called a net zero emission. So if you have a quantitative measurement of the carbon neutrality, the carbon footprint, we will measure the carbon footprint, etc. So the basic the unit is called net zero emission, which is the condition in which human activities results in no net increase in the greenhouse gas in the atmosphere, because all the human activity in the sense like we should not create any increase of greenhouse gas. Also, similarly the case with the industries, etc. So the human is the most important thing to create the net zero emission. So so we have to eliminate all the emissions we have been using, and there should be a balance. Whatever emissions remain through the renewal measures such as afforestation, soil, carbon storage, etc., or technological carbon capture. So net zero is now widely used as a central target in the global climate action. So we can see there's a global warming up to 1.5 degree in the pre-industrial level, and the world the target is net zero carbon dioxide emission. It should be the target focus on 2050. So we should have a delay in actions would force a sharper, more disruptive cuts later. So target we have to focus now on 2050 is net zero carbon dioxide emission. So in order to achieve this, there's a global urgency, right, on the maintain reduction of the carbon neutrality. For example, the global warming also, we should have a decline by 70 to 90% 2 degrees. So they must disappear. And also agricultural yields also, it declines, and which will threaten the food security. So, and small islands also face threats from the sea level rise and the heat waves. They have become more frequent and more entering human health. So carbon neutrality is basically is an environmental goal. It's a goal set by the UN, etc. But it is also safeguard for economies, health, and security of the nation. It is a coordinated action at every level. It's a global, national, industrial, and as well as the individual level also. So now let us see what are the applications of the sustainable engineering for carbon neutrality. First, the theories and principles which have been followed in the theories and principles which we have been followed in the sustainable engineering, which gains the application in the real world system. And the path to the carbon neutrality, basically there's a transformation across some various sectors of the society, like how we design and power our own buildings and how we transport the goods. So in the if you take an industry, we have to have the industry, the manufacture, the factory setup, etc. Then we have to design the products. Then we have to transport the products manufactured, and now we have to manage the waste. So all these are the pathways to create the carbon neutrality. So the green key applications where it is the driving change in the green buildings and infrastructure, renewable energy systems, sustainable transportation, circular economy, and material innovation. That's also we can have a replacement of the materials, which we can use eco-friendly materials in the process rather than the products which we manufacture, to ensure that there's no hazardous process involved in the systems. And also we can have that water waste management, better control of the water and waste management during the process. So right from industry, like we can see, if you take the building industry, like you can see the green buildings. Now the concept of green buildings and sustainable infrastructure. So the buildings, because buildings are basically the more contributors for the global gas emission. So they contribute to nearly 40% of the total energy consumption and 1/3 of the total emission. So we can have the basic, and also the traditional construction, because relies on large intensity, like they are using the cement, steel, etc. Both have a significant carbon footprint. So basically, we have a system to have an alternate for these products, and also we have the conventional buildings, so which is often vast amounts of energy for heating, cooling, and lighting, etc. due to the inefficient design. So that part also we need to take care. Sustainable engineering reimagines building as systems that harmonize with their environment rather than deplete it. So it harmonizes with the environment. So the green building basically focuses on the passive design. So the passive design means these structures, etc., are designed to take the advantage of the natural ventilation. So we are providing natural ventilation, sunlight, and shading, etc., to capture the solar heat, and strategically shading in the hot climate, which reduces the cool. Second is the high performance materials, like the innovation. We have to have a low carbon content cement material, then recycled steel. So that's now it is going on, like bamboo and post laminated timber, etc., which reduce the carbon emission during the construction activities. And the energy efficient also, we can have LED lighting, then HVAC system, high efficiency HVAC systems, etc., which reduce the energy consumption. So coming to the other areas like on-site renewable energy, so we can have a rooftop solar panels, etc. We can have wind turbines and geothermal systems, which allow the building to generate the part of the energy. Even the industries also, they follow this, all the systems like preheating. So the preheating of the process also, we are using the solar system. Then final heating is done by other heating media like steam or electricity, etc. So like that, we can have a carbon neutrality in the industrial operation, etc. Then the water management, like rain, we can have the green water harvesting, then grey water recycling, and also we have reuse the water for our process applications, or which reduce the strain on the freshwater sources. Then finally, we have the natural elements like green walls, rooftop building, etc., indoor plants, etc., which not only reduce the heat but also reduce the human comfort. So coming to the green infrastructure also, like roads, bridges, and public space, etc. So we can have a green roof system, etc. So which have impact on the heat. So green infrastructure generates more energy than it consumes, collects and treats the rainwater on the site, and uses composting toilets to eliminate the sewage, etc. So the approach is the construction industry can significantly reduce the carbon footprint and also improves the quality of the life for occupants. Then coming to the transformation from the fossil fuel, basically used in industries. So almost 73% of the energy sector is the contribution to the global greenhouse gas emission, which is responsible for the 73% of the total, and decarbonization of energy production. That is the heart of achieving the carbon. So we have to have a decarbonizing it on effect on the car energy production, etc. So in that we have to follow the technologies like newer technologies in sustainable engineering, having increased competency with the fossil fuels. So solar, because in solar system we have a solar panels in the process which convert the sunlight directly into electricity, and which also produce a solar thermal system which concentrate the sunlight to produce the heat. And we also have an engineering innovations like which increase the efficiency, cost reduction, and improve durability, and floating solar farms which also can be provided in the lakes and reservoirs, etc., which can be save land and reduce evaporation. Then of course wind energy. So we can have wind turbines with blades which having a longer than 100 meters, which have offshore wind farms in the deep waters, etc. We have an advanced systems which integrate the turbines into hybrid system with solar and storage to ensure power supply. Then also we can have a hybrid and a tidal energy which minimize the ecological disruption and also efficiently capture the ocean energy. Also we can have a geothermal and biomass energy which based from this earth crust, then renewable source, and biomass is from the organic material which is optimized to the feedstock like agricultural residues as well as the algae. So this is also a part of a system to reduce the carbon neutrality. Or then we have a small industries or small factories where we have smart grids, etc. We can have a digital energy network and also battery storage system which provide the hydro and green hydrogen production, etc. So that's a newer concept which stores excess renewable energy for the use. So now we can have a case study. We can see the wind turbines. If you take Denmark, they generate 50%, more than 50% of the electricity by the wind power. So it is the most innovative engineering turbine design and grid integration, which this country aims for 100% renewable electricity by 2030. So that's a great achievement. Now they are almost achieved in the border. So now the other area to be focused is about the transportation. Now the transportation accounts for almost 25% of the global carbon dioxide emission, with the road vehicles as the main indicator. So we can have an aviation and shipping and significant shares, and sustainable engineering is the mobility to reduce this emission. Then we have a electric vehicle, EVs, etc., which is powered by batteries, and they expanded battery capacity, improve charging speed, etc., and reduce cost. A charging infrastructure is being developed globally with smart grids, ensuring that EVs integrate seamlessly into power systems. Then we have a hydrogen fuel cells, which is used for heavy-duty applications like truck, ships, etc., which which produce electricity through a chemical reaction between hydrogen and oxygen, which emits only water vapor, etc. And the challenge includes the safe storage, distribution, and the cost reduction. So now we have public and shared mobility like sustainable transportation, etc. So we can have engineers, we can design efficient metro networks, bus rapid transit systems, and bike sharing platforms, etc. So we have autonomous electric shuttles, etc., which could revolutionize the urban mobility and reduce the emission. Then we have an aviation and shipping, etc., which explores the biofuels, synthetic fuels, and electric propulsion. Then we have shipping, which is experimented with the hydrogen, ammonia, and wind-assisted propulsion. Another example is the Norway. They are the global leader in the EV adoption. So more than 70% of the new cars being sold in 2023 being electric. So this success also stems from the infrastructure, government initiatives, and engineering. That also they have planned 2035. They should have 100% adoption of the EV systems. Now, for implementing this zero carbon neutrality, the basic one theory follows is like it is a concept called moving beyond take, make, dispose. Take, make is similar to our 3Rs technology. So the linear economy model, which extracts the raw materials, then manufactures the product, then the usage by the consumer, and finally after the usage, the customer dispose this product, resulting in massive waste and emission. So we have to have an alternate system like this waste should be an input to another industry, etc. So that we can ensure that sustainable economy or circular economy can be practiced, and the materials at each of the stages can be recycled or reused, and also this it should be process driven, and this output from one process should be the input for the other process, etc. And the intermediate from the one process will be the intermediate for the next process, etc. So this like that we can take circular economy. So this is called a take, make, dispose facility. Another concept is a product design for longevity. So basically we are The engineers are designing products that last longer and easy to repair and can be disassembled for recycling. So we should have like systems like more smartphones. Then this packaging also, we should have a reusable packaging materials and repairable appliances, etc. So that we can have a more focus with respect to the recycling. And then another point is like what I have told earlier, like an industrial symbiosis. There should be a mutual exchange between the industries, like the input upon output of one industry should be the input of the other industry. So there will be mutual exchange program between different industries. So the heat generated by one factory can be used for the other factory to have their district heating systems, etc. So like that, we can have an industrial symbiosis in a community platform. So other material innovation is biodegradable plastics. So we can have biodegradable plastics and carbon negative concrete, etc. So that we can absorption of carbon dioxide is less, and lightweight composites also, which can reduce the energy use in vehicles and aircraft. So then actually in Denmark, no, so there's a network of different industries which they exchange materials, water and energy in a system of industrial symbiosis, which they will be able to drastically reduce the emission and waste. So that is one thing. In India also, it's not being developed full far. There's a ample opportunity for this having the industrial belt or industrial area, GALAs, etc. The concept of industrial symbiosis. In India, then after this integration, then we have to have an integration of the system. So we have to follow an integration of the sustainable engineering practices to integrate the systems, which involves the renewable powered buildings, the EV based transportation, circular industry, an efficient waste system, which is a model for urban carbon neutrality. So basically, the smart cities, they integrate using the digital technology, which manage their energy waste, etc. Sustainable engineering, so it is not about isolated solution, but also it's a holistic thinking approach. Like so, we can think like how we can effectively reduce the carbon footprint, etc. Or in all the forms like energy reduction, then transportation, buildings, and designing of materials and disposal, etc. Now let us see an overlook of the carbon neutrality in the process industry. So if you take process industries across the globe, they contribute 30 to 40% of the global carbon dioxide emission. So there's a figure is great. So secondly, the energy operation impact climate change. So most of the process industries utilizes the energy intensity of operations, like especially the ovens, heating medias, etc. Like second is the regulatory investor and customer pressure. There's a lot of pressure from the part of the regulatory bodies, investors and customers, etc., to ensure the reduction of emission as part of building green manufacturing. So that also has to be owned. Then there's a lot of competitiveness and compliance with respect to these carbon neutrality and as well as the environment management systems. So that also being a part to be overlooked. So the pillars, so basically the pillars are sustainable engineering, energy efficiency, resource efficiency, pollution, the technological innovation. So energy efficiency in the industries, so we can have a waste heat recovery technology, like the waste, we can have the waste steam, where the steam generated, the waste steam can be there, that can be, it's called a condensate recovery process. So we can implement the condensate recovery process. So the condensate can be traced back to the boiler for increasing the economy of the steam for the boiler production. So now another operation is cogeneration system. So we can, other than steam for a boiler, etc., we can co-generate other systems, etc., along with the energy efficient process. Then finally, the advanced process control system like SCADAs, like etc. So which can have an impact on the energy efficiency. Then we can have efficient motors and drives, etc. We can have direct drives in the process, which will take care of the energy efficient aspect rather than the belt-driven aspects. Then coming to the resource efficiency, we can have a circular economy in the process throughout the product life cycle, followed by the water conservation, then byproduct conservation and sustainable sourcing. Then pollution control, so we can have cleaner production technologies, we can follow the principles of clean chemistry. Then ZLD is called a zero liquid discharge systems by implementation of ultrafiltration and reverse osmosis in the process, we can reuse the water or wastewater for process application and of course the air emission control. So coming to the technological part, we can have a digital twins for optimization of the process. Then we can have systems of AI as well as the IoT, Internet of Things, for the predictive maintenance of the equipments and technology. Then we can have a smart grids and renewable integration for smaller application process. And we can have an industry 4.0 and ensure sustainability. Then of course for carbon reduction, we can switch to renewable energy. Then we can, from the coal, we can convert to hydrogen. Then we can have an electrification process. Then low carbon supply chains can maintain. Then we can have a carbon neutrality strategies like carbon reduction measures, carbon storage, process innovation, and offsetting and carbon credits. So carbon credits can be mutually shared between the industries or between the various process owners so that the net effect of carbon will be compensated. So then it also includes the flue gas. With the flue gas in the process, we can adapt better technologies to reuse the flue gas and geological storage of carbon dioxide and effective utilization of chemicals and fuels, and we can have a global projects and examples. Then coming to process innovation, which in the industries we can have green hydrogen during the manufacture of steel and ammonia products, and biomass. We can have a biomass-based product for a smaller application like fermentation industry, like methane gas production industry, etc. And we can have an electrified furnace and kilns for the manufacture of cements or any other dried chemical products, and low carbon cement technologies, etc., for the manufacture of cements and other products. Then of how to offset the carbon credits, we can have reforestation and afforestation by planting trees and other things across the industry or the world. Then we have carbon credit mechanisms, which have a mutual exchange of carbon credits between the various industries. Then voluntarily carbon markets. So the voluntary donation of the industries towards the global market for the carbon. And of course, we can adopt the best practices from various industries, which can be used for offsetting the carbon credits. So these are the various things with respect to the techniques with respect to the carbon neutrality, and basically the technology wise, we can have a better control, and the communities also, we can have a better policy framework, and with the involvement of the people also. Basically, we have to create awareness and also the total involvement of the public, which have a large term effect on the low carbon future. Now let us see some case studies of the various industries, like the cement industries, for as part of carbon neutrality. So the first thing they have to do is they have to have an alternate fuels and biomass. Then there's a clinker, which is being mostly contributed, which has been produced as a byproduct, that mostly contribute for the carbon neutrality. So we can have a substitution process for the clinker, and carbon capture, the cement kilns. The kilns also, we can have a system to reduce to capture the carbon things, and we have a global leader strategies. Second is the steel industries. We can have a hydrogen-based DRI process, and electrification of the process, then circular scrap utilization, etc. And the major steel producers, the target is net zero roadmap. So that should be the target which has to be given to the major steel producers for ensuring the carbon neutrality. Then coming to other chemical industries, so basically the bio-based feedstock, etc. So we have a very good rapport with the suppliers, etc., to ensure that the products are ecologically free and is environmentally sustainable, etc. And electrified chemical plants. Then we have the carbon efficient catalysts which we can use. The examples of green adoption of the green chemistry adoption. So if we take the gloves, right? Take some examples from the rubber industry. So we take from the glove industry. So basically the basic thing is the glove. Basically the gloves also, it's a dipping process, a dip melting in the latex formers. Then it is then dried. So basically the drying, we can use the fired steam boilers in the glove. We can use the biomass system instead of fired steam boilers. Then the blended mass fuels, etc. We can do the wood chips, that's a feed to the boiler, etc. We can think of wood fuels, palm kernel shells, etc. So we can have the boiler efficiency maintained up to 78%. So we can reduce the steam cost, and also we can reduce the emission also. That is one thing. Second thing is the DPL gloves, Sri Lanka. So they switch over to the biomass fuel and heat recovery system. So they implemented the condensate recovery system. The biomass fuel they have been used, and their facility is certified for the new standard ISO 14064-1. That is 2018 standard, which accounts all the greenhouse gas account. It is a mass balance or material balance of the greenhouse gas emission, the process, etc. So this is a new standard which is being followed by industry to ensure that they are not contributing for the greenhouse gas emission. And also, of course, they have reported a 5% carbon dioxide reduction per glove meter. So that figure is very great figure. To each gloves, they have been reporting 5% reduction in carbon dioxide consumption, and also the sustainable biomass sourcing and reforestation have been implemented. It's coming to oil and gas industry. So basically, they are basically carbon capture hubs. So they have the low carbon hydrogen projects, and it has been transferred to renewables and the net zero pledges by the oil major companies. Then another glove product is called Hartlegia products that's in Singapore. So they have a published critical LCS for the latex products. Then they have the energy optimization and its emissions. They also transparent with the buyers and regulators. They have a very good relationship with your exchange of energy between these buyers and regulators, and the benchmark for the product. So they are using for the and the low carbon reporting also have been taken. So Malaysia is the major glove industry. So they installed the rooftop solar PV installation across the glove plant for indirect heating or as part of.
Sir will join in 5 minutes. Please stay.
Is it
Sir,
audible?
yes, sir,
I
audible.
actually, what stage, it is the connectivity has lost, because I was also not knowing that. So what stage this connectivity issue has happened? Well, I was explaining about these various case studies HLL has done as part of carbon neutrality. So that you have seen, no? Hello. So can you respond?
Yes,
So I
sir.
was. So at what stage, this it has gone corrected, no? So that's what I want to know.
Just 2 minutes, sir. 3
Just 2 minutes. So I will start with the carbon neutral strategies which HLL has done. So
Yes,
so
sir.
that I will repeat that stage. Okay. Is it visible?
Yes, visible.
Okay. So now we will start with the sustainability as well as the carbon neutrality. What HLL has done on the industry sector. So we are doing a lot of activities to reduce the carbon neutrality as well as sustainability. So one thing, the most important thing which we have done is, one is we have two types of technologies. One is a Japanese technology as well as a German technology for the manufacture of condoms. So the German technology is some areas is in manual operation. So what we have done is we have automated the one.
Sir, presentation stopped again. Sir, sir, you are muted. We cannot hear you. Sir, you are muted. We cannot hear you. Can any other participants hear?
Ma'am. Hello.
Yes, Anu. Can you hear?
I can hear your voice, but Venugopal sir is not able to.
Sir is saying that he is speaking.
Whether need to call sir and confirm the. Okay, sir joined.
മീറ്റിംഗിൽ ഉണ്ടെങ്കിൽ അതൊന്ന് മ്യൂട്ട്
Now, sir, you are muted. Sir, we can see you, but you are muted.
Okay, okay. Now it is
Yeah, now it is visible, sir.
okay, okay, okay. Is it visible now?
Yes, sir, it is visible.
Okay, we were discussing about this. So we have implemented the powder. Now it is okay, no? Audible is there.
Yeah, yeah. Sir.
Okay. So we have implemented the powder finishing, automation of the powder finishing. So basically the advantage which we are, there's a lot of savings in terms of crores. We have been annual savings in terms of crores for by implementing this in one plant. So we have saved in terms of material consumption, in terms of manpower savings. There's a lot of drastic reduction of the manpower and also the material. Also we have optimized the, because we have revalidated the process also, which yields the optimize the material consumption. Then the exposure of ammonia in the operators during the operation also, that has been also effectively reduced, and the product quality also improved, reducing in wastage and reduction. That is one of the things. Second thing is, so we have been using our RO plant. So we have a effluent treatment plant or ETP where we treated the wastewater, and this wastewater being used for our gardening application. So this one a portion of the water which we have been subjected to ultrafiltration, which is having less TDS, total dissolved solids, and RO, and then we subjected to ultrafiltration and reverse osmosis, and the RO water is equivalent to the drinking water, and this water we are using for our boiler and as a chiller. So almost we are daily we have been consuming 30 kL water for RO water for our application, etc. So we have dependency of Kerala Water Authority, almost 30 KLD consumption has been less by reusing this RO water. That is one thing. Third thing is we have been using LNG in place of furnace oil, like what I told you about for boiler application. So the LNG is it is coming as a cryogenic fuel. It is coming at a temperature of minus 165 degrees centigrade through the bullets and is then fired in a vaporizer. Then it is acted as a feed to the boiler in place of furnace oil. So absolutely there is no emission from the stack, zero emission. And the calorific value of this LNG is better than the furnace oil, etc. So that is all. This is the most important thing which we have done as part of the carbon reduction or carbon neutrality. And another thing is now this there's a CSR plus carbon neutrality. The ETP water, because the ETP a small portion only we are using for our RO plant, and balance the ETP water after treatment we are using for our gardening works and also for our cleaning works inside the factory. And balance almost 200 KLD water we are being discharged outside as per the concern of the Kerala State Pollution Control Board, and it is meeting the standards of irrigation standard. And we are constantly monitoring the effluent characteristic. Like it's an online monitoring system is being installed. So we get the readings at every 4 minutes for the treated effluent. And this water now we are having a tie-up with the Gold Scrub, Trivandrum Gold Scrub Extra, which is almost 3 to 4 kilometers from our place. We have provided a pumping station in HLL, and this treated wastewater wastewater, that is irrigation water, we have been pumped and is being transferred to the pipelines. Pipeline is being fed by the Kerala government, and this will be will be sent to the Gold Scrub, etc. And they almost this 200 KLD water they are using for for gardening their lawns, and we are giving it free of cost also. So that is so by that we will be able to implement the zero liquid discharge ZLD system. There's no emission of liquid discharge from the factory. And also from the process also we are using soap for our mold cleaning operation. So that 50% of this water that we are recycled from the process. So that is also being studied. Then also the condensate, the waste condensate from the steam traps in the process. So that we have been collected, and that will be conveyed back to the boiler by implementing the condensate recovery system, which will optimize the consumption of the steam in the boiler. Of course, we do a process optimization and process revalidation to ensure the material consumption and reduction of wastage and reduction as part at all stages of production. Also, we implemented a homogenization process of the compounded latex, which will avoid the uniformity in the film properties and which reduce the wastage and rejection, and also savings in terms of material consumption. Also, we have the recycled ETP. We have a waste treatment ETP sludge. So we have the ETP sludge, which is being treated as a manure. We conducted studies and proved that generally all the sludges are hazardous. So we actually proved that the ETP sludge is not a hazard; it is a manure because our sludge is having a constituents of the latex like NPK, nitrogen, phosphorus, potassium. So it is equivalent to a manure, and this ETP sludge we are using as a manure for our gardening inside the factory premises, etc. And also we manufacture bricks and lamp pots from the ETP sludge. So also we installed a solar power plant of 1 megawatt for preheating of condoms for post application, and we are having a daily savings of almost 400 units per day. And also we have installed a centralized silica slurry preparation in our workization operations in our of the technology, which will yield the large savings in terms of material consumption and also the water consumption, etc. So another lot of things we have done. This wet type technology, one testing machine we converted dry type, etc. So the steam has been totally illuminated. Steam consumption has been totally illuminated, and we also use the pipe lighting in the factory to have an artificial lighting inside the plant. Also, we have a biogas plant of capacity 25 m³ per day, which is used for the cooking of food in the kitchen, and the gas being used for the cooking purpose, etc. Also, we recycle the waste condoms for the manufacture of chappals and tire manufacturers, and also the pre-vulcanized latex we source for molding operation. We have a energy savings. We have a SCADA systems for compounding and molding operation, and also we have an online system of, like I told you about for mounting the ETP parameters. So these are the various things which are done. I will show you some photos. This is the automation of the powder finishing operation which we have. I told about the automation of the powder finishing operations. This is the photo of that. And this is the ultrafiltration and reverse osmosis process which we have commissioned 2 years back for making the water as potable water. Then this reuse of water, you can see almost for our RO process have been supplied to the chiller, boiler, etc. This 1 megawatt solar power plant which we are given as part of environmental initiatives. Product quality improvement like homogenization of latex which we have done. Then SCADA system which we have implemented for our substation. You can see the ETP effluent treatment parameters, like we have an online monitoring systems which we get the readings in every 4 minutes. You can see the lawns from this is a Goals Club. You can see before and after supplying this water, 200 KLD water free of course. You can see the condition of the lawns. We have done a revalidation of our waste treatment, ETP waste treatment plant. We also have a rainwater recharging of the open well near to our plant. So we all installed a new dual burner post-Marshall boiler for our process. And in ETP sludge also we make it as a compost. You can see here. It's basically I told you it's a manure, and that we also converted as a compost, and we vermicompost. We are additional cocoa peat in equal proportion of the ETP sludge. So this is the carbon footprint. This I told you, the LNG. It's a major contributor to the carbon footprint reduction because you can see the LNG is being gas from the vehicle. It is the vaporization. It is a vaporizer where this gas is being fed at a temperature of minus 165 degrees centigrade. It is having very good calorific value compared to the furnace oil, and is then preheated and goes to the feed to the boiler. So this is the LNG terminal in our place. This is a biogas plant it's a very old technology process which we are using, and we have a savings of almost 1000 kg of LPG units per year. And so these are the various applications like HL has done as part of energy initiatives. And this Denmark wind power pioneer that I've told you. Then this Norway also, the electric revolution is very detailed about that. And geothermal energy for sustainability we have seen. In India, we can see there's a global balancing of sustainability which reduce the emissions. And even the population exceeding 1.4 billion, there's a demand for energy infrastructure and transport. And we have a lot of solar energy producers in India. And we have mega solar parks, etc. And the engineers are designing metro rail systems, reducing the reliance on fossil fuel, etc. Then our target is to achieve net zero emission by 2070, a goal that will require massive development. So in that case, we have to have a massive deployment of this, all the sustainable, like any energy, renewable energy, then the EV vehicles, green construction, etc. So we should have a balance to ensure that the growth is sustainable. So of course, the Google, so each multinational company, they have a carbon neutrality plan. So the Google became the carbon neutral, you can see 2007, because they are the earliest tech companies and they have achieved energy efficiency, data centers, renewable energy purchase, and carbon offset. And they are able to operate entirely on carbon-free energy by 2030. It's an ambitious project, which is an one step beyond the neutrality. And they use the models of sustainable engineering, advanced cooling systems, and optimize the energy use. Then, of course, the carbon neutral products also, they have been used as part of the product life cycle. Apple also have been using, Tesla also, the batteries, lithium-ion batteries, supercharging networks, and autonomous systems also. They demonstrate that energy-driven companies are, of course, large intensity. They are contribute to the carbon neutrality. Then Copenhagen, that is they have a carbon neutral capital. So they're the world first carbon neutral capital by 2020 is in Denmark. So there's an investment in the cycling infrastructure, then district heating, then wind farms, etc. They produce clean energy, electricity, etc. And science, there's also zero waste city. So they have the goal of sending zero waste to the landfill, public through the campaigns and community and advanced waste sorting and composting facilities. And Bangalore also, of course, it comes under the category of smart city initiatives in the technical hub. So this project, they implemented a smart traffic management, solar power, street and waste to energy plants, and the expansion of the metro. And the lessons which we have studied from these case studies, we have seen the engineering innovation, that is one thing. Then policy and incentives matters. Second, third is the integration is the key. And the equal then participation, concentration from the public, and ambitious drive towards the progress. So that's ambitious projects they are taking. So these are the various lessons we learned from the case studies of various industries with respect to the carbon neutrality. And of course, we have a policy framework and global agreements in place. So the Paris Agreement, I think we are not going in detail. The main intention is to achieve net zero emission in the second half of the century. And UN also has a sustainability goal like SDG 7. There are totally 13 goals. We have SDG 7, 9, 11, 12, 13. It focus on the carbon neutrality and sustainable engineering, etc. So our focus is to achieve this by 2030. Then India, we can net zero. I told you about by 2070 we are target. And the challenges which we have faced during carbon neutrality, equity in transition, technological gap, and cultural and behavioral shift, and political will. And other challenges is high capital cost, then skilled force, then policy uncertainty, supply chain limitation. So finally, a call to action. Carbon neutrality is not just about reducing the emission, but it is for redefining the progress. And of course, that will improve the GDP, industrial expansion, material consumption, etc. Then the humanity also stands at a crossroad. One path continues to be a climate chaos and ecological collapse. The choice we have to find, the science is unequivocal, the technology is emerging, and it is undeniable. So the essence of sustainable engineering is about designing with the responsibility, and carbon neutrality is the ultimate benchmark of sustainability. So the humanity has learned to live in the ecological balance, producing no more greenhouse gases and earth systems, and we should have a intergenerational responsibility. We must borrow our planet for our children, and they must inherit the habitable world. So the final future outlook is net zero 2050 target, role of digitalization, hydrogen, then renewables, etc. game changers, business opportunities in sustainability, and finally conclude that journey to sustainable engineering and carbon neutrality is the defining challenge of our century. It demands courage, creativity, and cooperation at all levels. And we should have a promise of better world, one technology which support the human without destruction. And the progress is measured not in extraction, but in terms of regeneration. So the sustainable engineering ensures cleaner operation. Carbon neutrality aligns industries with the climate goals, and the global collaboration is critical and a pathway to long-term growth and resilience. So at this stand, the world of hope must be matched by the deeds of determination. So as engineers, we design the solution. Every policymaker enacted law. Every citizen should make a sustainable choice which contributes to the collective effort. So together we can create a future where carbon neutrality is not just a target, it's a reality, and ensures that the generation to inherit a planet not in crisis, but in the balance and flourishing life. So the way forward is clear. Sustainable engineering is the foundation. Carbon neutrality is the goal, and global collaboration is the path. So the human humanity chooses wisely, the 21st century will be the remembered not only for the climate crisis, but also for the transformative responses where we reimagine progress, restore balance, and to secure the earth for all who call it home. Thank you so much.
Thank you, sir.
Okay.
Any of the participants has any
Have any questions? So how do you find this presentation now? Is useful? So just I want to have a feedback from the participants about the areas which I have covered, whether this was useful or covers all aspects of carbon neutrality with respect to the industries. What's your feedback?
Good evening, sir. I'm Anu N.
Okay.
In BPM College of Engineering. It was a nice presentation. I would like to know about a few things about the carbon credits and its certificate.
Okay.
Sir, whether how it is mechanized, the carbon credit certificate and the monitoring, who is the authority, whether MOEFC or Pollution Control Board?
Okay. So I will answer it at the end. That is one thing. Okay.
Okay,
That's
sir.
one question.
Fine, sir.
Any other question? That is one question.
Participants can ask any questions if any.
So another question, but I need some information about. Can you move? Some question. Somebody, Mr. Hari Kumar or something. Yes, given a question.
Whether in reality an engine or installed based on an ammonia fuel. That is one question, sir.
Can you repeat now?
About ammonia, whether it in reality any engine are installed based on ammonia fuel.
Okay. Okay. Any other question? Any other question? What is the gaseous fuel in carbon emission? What is the role of gaseous fuel? Okay. Shall I repeat? Shall I answer the questions now? So we have 3 questions.
Yes, sir. I think we can.
Okay. So the first question, Dr. Anu has asked about the certificate. No, actually, there's a new standard now it's a greenhouse gas and GST emission standard. It's called ISO 140604. That's a new standard. So even though the standard was evolved in 2018, it was not mandatory. Now what happened? This Ministry of Health and Ministry of Environment and Forest, in consultation with the Central Pollution Control Board, not Kerala's pollution, they actually identified a lot of agencies like ISO 14001, like TUV, etc. So they have been interested to provide the certifications for this carbon emission one. So this ISO 14064. So almost all of this now it becomes a mandatory. Like earlier we have like environment sustainability report, which has been given by the industries to ensure that it's not is environment friendly. Like that, no. Now it is a responsibility of any industries creating using the energy they have to ensure that there should be a proper energy balance between which is to be followed by the companies and which to reduce the greenhouse gas emissions. So that is one thing. So for that only, this standard has come. ISO 140604. So now this is being certified by various like TUV, TUV, etc. Then TUV is there. Then TUV Node and SOD is there. Then we have SGS also. They have also been certified for this ISO 14064. So that's a recommendation based on the standards framed by the Ministry of Environment and Forest. And also there's another standard called ISO 50000. Basically, it's an energy management system. So that also it takes care of the energy balance, energy usage, etc. Energy-based indicators, etc. So that also that is not directly relating with the greenhouse gas emission. Of course, that will have an impact on reducing the carbon emissions. So that is the mechanism which follow. Now it is now implemented only. Now it is now within 1 or 2 years it becomes a mandatory for all industries, like energy audits, like every industries are doing that. So now it becomes a mandatory in another 2-3 years. Is it clear?
Yes, sir. Yes, sir. Clear, sir.
Okay. And second point is about the ammonia fuel. So basically that ammonia, why it is not being used in ammonia? Because ammonia is one of the reason like that, no? The ammonia gas, the gaseous emission, it creates the damage to the engine in terms of ammonium hydroxide, etc. So what happened is, and also it is corrosive also. So the life of the engine will be affected also, and process also the process also, like the operators or the users using this ammonia as a fuel also, they find also it's environmentally not sustainable also in the process. And it is being that's why it is not being used as a fuel for the fuel ammonia as a fuel. So it is ammonia is it's a stabilizer of the process. That's all. Is it okay? Okay. Third point is, what is the role of gaseous fuel in carbon emission? There's no, with the carbon emission, the gaseous fuels from the carbon emission is carbon monoxide and carbon dioxide. So what happened during the process? The carbon monoxide, if there's in the boiler, if you have a raw material like carbon, if you have a furnace oil, it may have during cracking, no, it may have carbon monoxide, SO2, NOx, etc. So finally, our main objective is to convert the carbon directly to carbon dioxide. But what happened? It is not. It is only partially convertible to carbon dioxide. Some of them it will be kept as a carbon monoxide. So that carbon monoxide will act as a highly pollutant also. So it will not be converted. If it is converted to carbon dioxide, it's okay. So it always reduces the efficiency of during this process, during this operation of the boiler, etc. So the uncombustible carbon creates the carbon monoxide, etc. So this carbon monoxide, we cannot treat this as a fuel, etc. So the emission from the carbon monoxide is more dangerous than carbon dioxide, etc. So our ultimate aim is to bring down the carbon monoxide to ppm, 0 ppm. So that's why. Otherwise, now what will happen for the engines, etc. The life of the engine will be affected, and the cracking also happens, etc. So the role of gaseous fuel, the carbon monoxide, the purpose is you have to it is to be 100% degraded to carbon dioxide. Carbon should be completely converted to carbon dioxide, not partially combustible. Okay. Okay. So what I find is now this is a new era. I think I have a suggestion in that, since the theme selected for this FTG is very accurate now. So if you want to implement this in our state, in our country, I think this is the opportunity. These people, all these participants now. So even if we can have a group and also we can have debate themselves and you can implement their systems, etc., that will be highly helpful for the nation. That's what I feel. So it is SAIBI, if it is possible, we can create a group for these people and let their contribution in terms of reduction of carbon monoxide or carbon dioxide or carbon neutrality by implementing a sustainable process. If we can collectively, if everybody can contribute that also, that will be helpful for our nation as well as the society. Just we can have a think for that, because we have a large group, almost 75-85 people are there.
Yes, sir, sure. We have around 150 participants.
Yeah, that's fine. Because it's a mixed group containing industrialists, maybe the parts of this Even though today the participants may be academicians and other industry people are also there. So we can have a good system by having in place so that we can think of that. So that will be the takeaway of this FTG session also.
Yes, sir. We have participants from all over the India. Like if they are mostly are faculty members of engineering colleges.
Okay, sure. So technology as well as implementation in the industry, so that will be definitely helpful for reducing the mortality. Okay. You know, we are complete this on time, so by 7:30 we are complete.
Yes, sir. Correct. Correct. That's the
Okay,
part.
thank you.
Is there any further questions?
Any questions? Actually, we have done lot of sustainable activity. We are just showing only some of the few aspects only. So that we are showing that it will take more than 2-3 hours. That's right. Whether IC engine is completely reduced before? Yeah, sure, definitely.
Okay, sir. I think there are no
Okay,
other.
that's it. Okay. Okay, thank you so much.
Thank you for your wonderful session, sir. Thank you.
CNG LNG. What do you ask about CNG LNG? What information you know about CNG or LNG? So this I think I have discussed about LNG, CNG both because it is having a good calorific value, and this what also I see. What do you mean? This question is not clear. How the CNG LNG about IC? That's okay. Okay. How it is because the CNG LNG basically it is having a very high calorific value compared to the other engines. So that is what engine. So it is vaporized at a temperature of minus 165 degrees centigrade, and is sent to the vaporizer. So what happened now? The combustible, it is highly combustible. I mean, all it has been fully 100% comes an exhaust gas without carbon because there's no emission of carbon monoxide or carbon dioxide. It's 100% combusted and it's a clear fuel. And there's no, you cannot see, it's a clear fuel, it's completely oxidized. And there's no emission of uncombustible carbon monoxide or carbon dioxide or any other particles as we've seen in the input of the, because LPG's LNG CNG does not have a like sulfur or some other contents, etc. So it is absolutely there's clean oxidation, 100% oxidation happens, and also basically it has full combustible happens, and there's no emission from the engine. So there's zero exhaust. Exhaust is there's no need of providing an exhaust in the vehicle. Okay, thank you.